This will be for the con exercise. Solve sinusoidal equations, basic. Okay, some things you need to know for this exercise, and I'll explain why these are true in another video. Okay, you want to remember that the cosine of x equals the cosine of negative x. Okay, x is representing the angle measurement, and the cosine of x equals the cosine of 2 pi plus x. The sine of x equals the sine of pi minus x, and the sine of x equals the sine of 2 pi plus x. Okay, you want to remember that pi equals 3.14 in radians, but in degrees it equals 180 degrees. All right, some of these problems are going to be in radians and some of them will be in degrees. So for the ones that are in degrees, you can make this 2 pi 2 times 180, which would just be 360. Okay, so if the problem is in degrees, that's just going to be 360. In fact, many of the problems some of the problems I may convert to degrees, even if they're in radians. Okay, but these expressions in parentheses represent the angle measurements. Notice that these two identities are basically the same for the sine and the cosine, but this one only applies to cosine, and this one only applies to sine. So for all of these problems, they're going to involve inverse sine or inverse cosine. All right, there's going to be a short write-up, and there's going to be steps here that the person took in solving the equation, and then they ask where the mistake was. So that's how these problems will go. All right, Everlay tried to solve the following equation where x is in radians to the nearest hundredth. That's 2 decimals in the interval from 0 to 2 pi, but she made a mistake. All right, so the problem is in radians. All right, and the interval is from 0 to 2 pi. So all of the answers for x have to be in between 0 and 2 pi. But I would rather convert this 2 pi. So I'm going to say that the interval is from 0 to 360 degrees. All right. So that's going to be the interval. And let's see. So I do these myself and see where my answer doesn't match the person's answer. All right, so they said this was in radians. All right, and they gave us that the sine of x is negative 0.28. So in order to get x, that's what we're looking to get. In order to get x, we need to do the inverse sine on both sides. So it's going to be the inverse sine of sine of x and that's going to equal the inverse sine of negative 0.28. I'll just put 0.28. I don't have the room here. Okay, so I did inverse sine on both sides. Inverse sine and sine cancel. And x equals this. You need the calculator set to radians, okay? So do this in radians. And rounding off, I get negative 0.28. So that's what this person got, so that step is correct. Now you want to remember, if you go once around the circle, if you add 360 or 2 pi to the angle theta, you're going to end up right back where you started. Okay, so you're going to get the same value for the sine of x. So we're going to start with x equals negative 0.28. And what we're going to do here, we are going to add or subtract values of 2 pi. Okay, because 2 pi is once around the circle. So if we add or subtract 2 pi, we end up in the same spot and we'll get the same value for x. We said in the beginning that for radians, this problem is in radians, pi is 3.14. So 2 pi is just going to equal 6.28. All right. And there's supposed to be an n here, actually. And in this case, n is just going to be 0, 1, 2, etc. Okay. We're adding or subtracting multiples of 2 pi to this value because you end up in the same spot. Anyhow, we have negative 0.28, and we're going to add or subtract. Instead of 2 pi, I'm going to plug in 6.28 times n. All right. So we're adding or subtracting multiples of 6.28 to this number. Now, it said in the beginning the range of values for x is from 0 to 2 pi. So that's going to be 0 to 6.28. All right. So we want to get values of x that are in this range. All right, let's see. So for the first one, negative 0.28, that's not in the range, but we can try adding or subtracting 6.28. Now, if we do negative 0.28 minus 6.28, it's just going to be a bigger negative, and that's out of the range. But we can do negative 0.28 plus 6.28, okay? And that will give us positive 6, or you can say 6.0. So that value is in the range. Now, if we add 6.28 again, we're going to get 12 something. That's out of the range. So this is the only answer. Now for the identity, we said at the beginning, sine of x is equivalent to sine of pi minus x. All right. So x is going to equal pi, which is 3.14, minus the original value of x, which is negative 0.28. Okay, the two negatives in a row make it positive, and we get x equals 3.42. Okay, so once again, we are adding or subtracting multiples of 6.28. All right. So let's see. If we do 3 plus 6, we're going to get 9 something. That's out of the range. If we do 3 minus 6, we're going to get negative something. That's out of the range. If we do plus or minus 0, we can keep the 3.42. So that one is within the range. So the answers are 6 and 3.42. Now this person's solutions, this person got negative 0.28, 3.42, and 6. So this one and this one are good, but this one is no good. That one is out of the range. See, it says negative 0.28, but they said the range at the beginning was from 0 to 2 pi. So that was the mistake right there. It's out of the range. All right. So Everlay gave a solution that was outside of the interval. Answer D. All right, Kelly tried to solve the following equation where x is in radians to the nearest hundredth in the interval from pi to 4 pi. All right, so it goes from pi to 4 pi, which means it's going to be 3.14 to 4 times 3.14. Okay. And this is going to be 12.56. All right, so this is the interval we're looking for in as far as the values of x are concerned. Anyhow, right here, in order to solve for x, you need to do inverse cosine on both sides. Okay, so we're going to do inverse cosine of the cosine of x. And we're going to do inverse cosine of negative 0.35. On the left, inverse cosine and cosine are gone. And this I'm going to do on the calculator. You have to make sure this is in radians. All right, so you need to be set to radians. And I get x is 1.93. So far, so good. Okay, sometimes the mistake is right there in that step. So the range of values for x are from pi to 4 pi. Since this is in radians, I use 3.14 for pi. So this is my range of values. All right. So for the cosine of x, this was the x that we originally got. We're going to add or subtract multiples of 2 pi. Okay. In other words, we take the original x, we forgot the n here, and we're going to add or subtract the 2 pi is 6.28 times n. Okay, and the values have to be in this range. So the 1.93 doesn't count. Let's add 6.28. Okay, and if I do 1.93 plus 6.28, I get 8.21. All right, that is in the range, so that's good. Now, if I add 6 again, I'm going to get 14 something. That's no good. All right. Also, if I take 1.93 and subtract 6, I'm going to get a negative. That's no good either. So this is the only one for the cosine of x. All right, now for the cosine of negative x. The original x was 1.93. I'm going to take the negative of that, and it's going to be negative 1.93. Okay, and once again, plus minus multiples of 6.28. All right. So let's see. If I do negative 1 minus 6, I'm going to get a negative. That's out of the range. So let's try adding 6.28. Okay, I think that will work. So negative 1.93 plus 6.28 is going to equal 435. That's in the range. That works. What if I add 6 again? Well, it's going to be 10 something. That will be in the range. So let's try 435. Plus 6.28 again. And let's see, plus 6.28, I'm going to get 1063. All right. So that one works as well. Now, if I add 6 again, that's going to be out of the range, so that's no good. So these are the 3 answers right here. All right, let us compare. So this person got the value for x correct and then added 2 pi. Okay, but he or she never did the cosine of negative x. All right, so there should have been more work on the other side here for the cosine of negative x. This person never did that. All right, he or she only did the cosine of x. So he or she didn't use an identity. That's okay, that's a she. Kelly forgot to apply an identity, which would reveal more solutions. There you go. All right, I can do this one real quick. This problem here is in radians. Okay, you need to do the inverse sine on both sides here. So inverse sine of the sine of x is going to equal inverse sine of 0.71. On the left, it cancels. And again, this is in radians. If I do this on the calculator in radians, inverse sine of 0.71, I get 0.79. But this person got x equals 45.23. So he or she was not set to radians. It looks like he or she did degrees. So that's your answer. Answer A. So-and-so evaluated in degrees instead of radians. Okay, so sometimes you won't have to go through the whole problem. All right, just check the original statement for x, the original value of x. That might be the mistake right there. Kong tried to solve the equation. X is in degrees to the nearest tenth. Interval is from negative 360 to 90. Okay, so here we are, cosine of x. Do the inverse cosine on both sides, and you're going to end up with inverse cosine of 0.34. All right, so now we're in degrees. And if I do inverse cosine of 0.34, I get 1.2. Hold on, that was in radians. In degrees, I get 70.1 for the value of x. So that's what he got. So far, so good. Let's apply the identity for the cosine. And again, take note, the interval goes from negative 360 to 90. So we're dealing with 70.1. Okay, now we are dealing with degrees. We know that once around a circle is 360 degrees. So for this right here, we're going to add or subtract multiples of 360 times n. All right, so instead of 2 pi or 6.28, we add or subtract 360. Now let's see. The 70.1 is good. That falls within the range. So we're going to keep that value. Okay, and if we add 360 to 70, that's going to be more than 90, so forget it. So let's try subtracting 360. If we do 70.1 minus 360, I get negative 289.9. That is in the range, so that one is good. Now, if we subtract 360 again, that's going to be less than negative 360. So these two are the only two for now. And now for cosine of negative x, we're going to take the negative of the original. So that's going to be negative 70.1 and add or subtract multiples of 360. All right, if we take negative 70 and subtract 360, it'll be less than negative 360. So I am going to add 360. All right. And I get 289.9. And that is greater than 90. So that one is out of the range. All right. So the original from the negative x is the only one we can keep. All right. Like I said, if you subtract 360 from this, it's going to be less than that. So we have 70, negative 289, and negative 70. All right, so here are his solutions, and we are missing the negative 289. All right, and you would have gotten the negative 289 if you applied 70.1 minus 360. So that's what's missing. So he forgot to add or subtract one of the multiples of 360. All right. Kong forgot to use negative n values, which would reveal another solution. So that's what it is. All right. Remember we said minus 360n. So n would have been, if it was plus 360, n would have been -1. All right, so that's what he forgot. Answer C.